Hi everybody. Before we get started with this week's new topics, I would like to take a few minutes and review functions. Functions are extremely important in this course, so it's really important that you guys have a very good handle on them. So far we have talked about functions in terms of pass by value. So what that means is if you have consider a function setup, and we'll say we have int a and b, and let's define a function foo, which has x and y, and it has a return type of int. Let's say this function takes x, increases it by 1, y increases it by 1, and it returns only x. So it's just a function that's doing something. And I'm going to go ahead and call this function, and I'm just simply going to say int result equal foo b and a. So if we draw the memory diagram for this, and in the studios have been emphasizing memory diagrams because memory diagrams are extremely important, and as we go on with the material, you're going to see how useful they are. So for something like this, we start from the calling function, and basically the memory of the computer, it stacks up, right? So you start from the very first function, which is setup. So we have setup, and in setup we have a is 10, then we have b, which is 20, we have result, which is currently set to garbage, but we do a function call, and we are going to go ahead and go to foo. So let's say if we have another line here, for example, print ln, and we're going to print result, our function is not going to obviously print anything. It's going to go to foo. So now the control of the program is in foo. Setup has no control over the program until we come back from foo. And actually I do have a mistake here. This is supposed to just say return x. Okay, so we call foo. So foo is created. And I said that we're going to divide up the function's memory into two halves. One is going to be for parameters. So foo is going to have two parameters, x and y. And it basically has no local argument. So I'm just going to write no local. Now we are right over here right now. And basically when we call foo, we're going to copy the arguments that we pass in foo in the parameters, right? So we are going to copy these in order. B is being passed first, so B is going to get copied into x. So B is going to get copied into x, so x is going to be 20. And A is the second one that's being passed, and A is going to get copied into y. So y is going to become 10. Now, basically, you should cover up function setup because we don't look at setup anymore, right? We don't look at setup at all anymore, and we're just in foo. So when we are in foo, we say x plus plus, so x will become 21. This is why this method is called pass by value. That means the value of b has been copied into x. So if I change x, b is not going to be changed at all. It's passed by, because it's passed by value. Its value has been copied. So if you copy a file from your desktop to your My Documents folder and you change it in your document folder, then that file does not change in your desktop, right? Because it's a copy. They're completely unrelated. So now x is 21, and of course a or b doesn't change at all. And then we have y plus plus, so y is going to become 11. Then we're going to say return x. When we say return x, basically foo shoots x back to the calling function. It speeds it back up, it shoots it back, and at the same time it dies off. So when we say return, it sends x and it dies off itself. When it sends it here, it so happens that result is waiting to catch the result of the return value of foo. So the return value of foo happens to be x, which was 21. So result is going to have the value 21 inside. We're going to print results. So the output of this program is going to be 2021. So that should be very clear to everybody. In pass by value, the inputs are the parameters, and you have a return type that could be void sometimes, depending if you want to send data back to the calling function. I also wanted to have a look at this problem that you guys solved in your in-lab or in-studio project 6. And I thought that most of the people have figured this out, but I just wanted to quickly go over it so you guys could follow along, and hopefully we are on the same page. So I asked everybody to draw a memory diagram, and hopefully you did. So we start with the setup function, as always. Basically, you're going to have the global values. First of all, the global is actually first. So global values, you have a, and that's 10. Then we start with the setup function. So we'll just be down here, and that's setup. In setup, we're going to have B, C, and D. So B is garbage, C is garbage, and D is garbage. Then we're going to assign 18 to B. So B is 18. And we're going to assign 2 to C. So C is the value 2. And D is still garbage. So at point 1, if you put a print statement, if you actually said, so for example, right here, if you said print A, B, C, and D, what is going to be printed at this point? Well, first of all, we're going to get an error message for D because the value is garbage, so it says it's not initialized. So this code won't run, but if you say A, B, C, and A, B, and C, it'll run. So for A, we're going to output, so at that point, the global A is apparent. So A is gonna be printed as 10. When you say B, the computer, of course, sees the local B, which is 18. When you say C, the computer sees the local C, which is 2. And D's, of course, D exists. You have a variable D, but inside of it is garbage, so you put a question mark. All right. Just gonna delete this. And let's continue on. Then we say D and we call foo. When we call foo, the control goes from, so you don't have any control in setup anymore. Control is passed now to foo. So foo gets loaded on to memory. So here we have function foo. And with the name foo, of course, you can call a function anything, right? It's better to come up with meaningful names, but here in this particular function, name is not important. We're investigating what's happening in memory. So in foo, we're passing A and B, and they are function arguments. So we have A and we have B, and there is no local arguments. So we'll look here, and we are basically, so it's B is being copied into A and C is being copied into B. So the value of B is being copied into A, so A is going to be 18, and the value of C is going to be copied into B, so this is going to be 2. Now you have to pay attention when you're in foo. B is different from the B in setup. There are two different variables in two different scopes. So right now we are in foo. We're not looking at setup. So we're not looking at setup at all. We're only looking at foo. So right in here, if you put print B, this is going to output 18. Oh, sorry, this is going to output 2 because it's looking at B in foo. It's not looking at B in setup because you're in foo's scope, right? So that's quite important. Then we say A++. So when we say A++, which A are we talking about? We're not talking about the global A. We're talking about the A that is within the scope of foo. I've used this example to many of you in the labs. It's basically like government. If you have a municipal government, if you have a question, you go to your municipal government. If you don't have a municipal government, if you have a question, you go to your provincial government. So if you have a question, you won't automatically go to provincial because you have the municipal court system or government to go to. So if you have a variable that is within the scope and they have the same name as the global, that's the variable you want to go with. So when you say A++, you're talking about this this A, and this is gonna say 19. Again, by the same token, right in here, if I said print, so right in here before I say A++, if I say print A, of course you're not gonna, the computer doesn't see the global A, it sees the A that is within the scope of foo, so it's going to print out 18 before you do A++, right? So then we do B minus minus. So B is gonna become 1. And then we say A plus and we call bar. So bar is being loaded onto memory. This is bar. So the control is out of the hands of foo, and the control is in bar right now. So in bar, we're going to send B, and B is going to be copied in D. The value of B happens to be 1, so D is going to contain 1. We do have one local variable, which is C, and C is going to have a D plus 10, so C is going to have the value 11. So now we are at point 3. Some point 3 happens before point 2. So at point 3, again, if you said print A, B, C, and D, what is going to be printed out? Do we have A in D? Well, we don't have a local A in D. We don't have an A in the scope of bar. So what happens is we're going to look at the global A. So A is actually 10, which is the global A. Then we say B. Do we have a B in bar? We don't. So it doesn't exist. So it simply doesn't exist. What about C? C we do have. The value of C is 11 at 0.3. And what about D? Do we have a D? We have a D. The value is 1. All right. Then we say return C. That means we return the value of 11. When we say return C, bar is going to die, so it doesn't exist anymore, right? When we return C, the value of C, we don't have a variable catching the value of C, but the value of C goes into the place of bar. So now here we have this equation. We say A equals A plus bar B, and instead of bar B, we put the value 11. So it's going to be A equals A plus 11. A is 19. A is going to become 30. And right at this point, again, you have to print everything that you have. So print A, B, C, and D. So at point 2, what is A? A is 30. What is B? B is 1. Because we're looking at the scope of foo. And what are C and D? There are no C and D's in the scope of foo. So we're going to get not applicable or not available. And then we're going to return A plus B. So what is A plus B? A plus B is 30 plus 1. So that's 31. So we return that, and foo is going to die. When foo dies, we go back up here, and the result of foo is going to be saved in D. So D in setup is going to become 31, because that's what's returned by foo. So at point 4, when we again want to print A, B, C, and D, A is going to be the global A, because there's nothing in setup. So we get A as 10. We get so now we get for B we have 18. C is 2, and D is 31. And that's what we have. So when setup finishes, setup is gonna die off and leave memory as well. So hopefully you fully understand the process here. If you don't understand this, please make sure to ask one of the tutors or your TAs or myself or Emily. It's very important that you guys fully understand this problem. All right, thank you.